Hello, my name is Gregory. I work with the U.S. Geological Survey, South Atlantic Water Science Center, with our office located in Norcross, Georgia. The title of my talk is Saltwater Intrusion in the Floridan Aquifer System near downtown Brunswick, Georgia. Support for this work has been provided by the Brunswick-Glynn County Joint Water and Sewer Commission and the Georgia Environmental Protection Division. The Upper Floridan Aquifer is the principal source of water supply in coastal Georgia. Pumping has lowered groundwater levels throughout coastal areas. Water level declines near Brunswick has resulted in saltwater contamination over a 2.5 square mile area. Migration of saltwater has spanned 60 years with maximum chloride concentration more than 10 times the EPA's secondary maximum contaminant level. Major structural features of the Floridan Aquifer system shown on the right include the Gulf Trough, Southeast Georgia embayment, and the Beaufort Arch. The earliest wells flowed at land surface throughout much of the coastal area. Water levels were about 30 to 40 feet above land surface at Savannah and 65 feet above land surface at Brunswick. Prior to the 1950s, groundwater pumping was limited to scattered pumping centers near major towns such as Savannah, Georgia. Major industries developed and local populations increased in coastal Georgia cities, resulting in greater pumping. Pumping in Glynn County, shown in lower left, large-scale pumping began in the early 1940s and peaked around 1980, with mean annual pumping rates of nearly 60 million gallons per day at Brunswick Cellulose and 20 MGD at Hercules and nearly 10 MGD for public supply. Saltwater was first detected in the Floridan Aquifer system in wells completed in the Upper Floridan Aquifer near the southern part of the city of Brunswick in late 1957. By the 1970s, a plume of groundwater with high chloride concentrations had migrated northward towards industrial pumping centers. Since 1965, chloride concentrations have steadily increased in the northern part of the city. The shape of the chloride plume, shown above, has remained relatively stable since 2000. In 1978, data obtained from a nearby 2,720-foot deep test well showed water with a chloride concentration of 33,000 milligrams per liter, suggesting the saltwater source was located below the Upper Floridan Aquifer in the Fernandina permeable zone of the Lower Floridan Aquifer. The project was first initiated with City of Brunswick in late 1950s. Annual sampling has been performed over the past 25 years. Average of 50 wells sampled yearly, 48 sampled in 2020. Groundwater samples are collected from flowing wells, active pumping wells, and using airlift inside well casings. October of 2019, 34 samples were collected in the Brunswick area. Chloride plume defined, shown in blue, as areas with concentrations greater than secondary maximum contaminant level of 250 milligrams per liter. Areas of maximum chloride concentration, shown in red, are nearly 10 times SMCL. Data indicates one possible source of salt water at Bay Street to the north and another at Reynolds Street to the north. At these locations, the mechanism of saltwater intrusion shown above is likely vertical hydraulic head gradients and conduits fractures that allow upward flow from the Fernandina permeable zone in the Lower Floridan Aquifer. Public supply wells in Brunswick Villa and Goodyear Park shown in the map on left are located within a half a mile of the northern chloride plume boundary. Public supply well Coffin Park is located within 3/4 of a mile east of chloride plume boundary. A comparison of chloride values 2019 and 2020 collected at 22 wells indicates a mean decrease in chloride of 56 milligrams per liter. Decreases in chloride in the northern part of the plume area range from 40 to 320 milligrams per liter. Decreases in chloride in the southern part of the plume area range from 46 to 400 milligrams per liter. Several wells show increases in chloride concentrations which range from 41 to 73 milligrams per liter. The real-time monitoring network was established in 2009 around the perimeter of the chloride plume for water levels and specific conductance. Water alert system provides email or phone messages when threshold values are hit. One of the following slides will include specific conductance data collected from the Brunswick Villa well for the period of record. The map on the right shows the location of these real-time monitoring wells. Brunswick Villa well is located in top portion of the map north of the chloride plume. These photographs show basic components of real-time monitoring wells, which include data logger installed inside well shelter, satellite telemetry to transmit data to USGS website, pressure transducer positioned below water column inside well casing, water pumped from well directed to flow through chamber to measure specific conductance. Looking at the record for the Brunswick Villa well, which the period of record is 2009 to 2021, equipment installed in late 2009, initial period of specific conductance below 500 microsiemens per centimeter from 2009 to 2011, period of missing record in 2012, specific conductance increases above 700 microsiemens per centimeter starting in 2013. Sharp decrease in mid-2015 corresponds to plugging of lower portion of well. Specific conductance above 800 microsiemens per centimeter during 2017 and 2020 and below 700 microsiemens per centimeter during 2019. Values generally show downward trend over past 2 years. Chloride can be estimated based on specific conductance monitoring in real-time sites. Background levels in chloride concentrations in Upper Floridan Aquifer range from 20 to 30 milligrams per liter and correspond to specific conductance values below 500 microsiemens per centimeter. Specific conductance data from Brunswick Villa well, shown in previous slide, had values ranging from 700 to 800 microsiemens per centimeter, and correlation indicates and predicts chloride concentrations ranging from 90 to 110 milligrams per liter. Spatial distribution of potentiometric-surface contours, shown in blue, indicate groundwater flow directions toward the coast and major pumping centers. In the Brunswick area, groundwater flows from the west, north, south, and southeast toward the city. The potentiometric surface map of Glynn County shows a cone of depression near Brunswick, and the regional potentiometric surface map of the Upper Floridan Aquifer shows other cones near Savannah, Fernandina Beach, and Jessup. Spatial distribution of potentiometric surface contours, shown in blue, define the water level elevation in the Upper Floridan Aquifer at a given location. Groundwater flow lines, shown in red, are always perpendicular to potentiometric surface contours and are influenced by the hydraulic head gradient in the Upper Floridan Aquifer. Map on right shows how potentiometric contours in groundwater flow directions influence the shape and chloride concentration in the plume area, with flow paths ending at pumping centers. I would like to end by thanking the many people who have contributed to the project over the years.